Hi everyone, the two videos that you have watched earlier are the integration knowledge that I expected of you because your methods teacher have taught them in class. So what is with specialists, we will still talk about integration of trigonometric functions. But we will be exploring on integrating sine x to the power of n respect to x and cos x to the power of n respect to x. So how do we perform integration on such trigonometric function? We will need to first convert sine x to the power of n or cos x to the power of n into another form by using trigonometric identities. And where can you find these identities? You can look for them in my second manual on page 31, or you will see them in the Math Specialist formula booklets. Okay, we are going to talk about two examples, and let's look at the next slide. The first example will be on page 32 of my manual. Example 1, page 32, part B. So what are we going to do with this example? We will be integrating sine square x with respect to x. Alright. So what did I tell you earlier? I mentioned that you will need to convert this trigo function with power into another form, and that form mustn't have power in it by using specific trigonometric identity. So what identity do we consider over here? Maybe cos 2x equals to 1 minus 2 sine square x. Why did I pick this identity is because sine square x is what we wanted to rewrite in another form. Therefore, if you were to rearrange this identity, you should be able to get sine square x in the form of 1 minus cos 2x divided by 2. When you look at this expression, it isn't any power anymore. Therefore, you can integrate like normal. Sine square x is equivalent to 1 minus cos 2x divided by 2. Half is just a number, so leave it outside the integral. Leaving behind 1 minus cos 2x to be integrated with respect to x. What do you get when you integrate 1? I bet all of you could answer this. X. And what do you get when it is integration of cos 2x? It will simply be sine 2x divided by 2. Since we are performing integration on an indefinite integral, please remember to add plus c. Alright, continue on. We will have another example discussed. This will be again example 1 on page 32, and it will be part C. Part C requires you to integrate cos square x with respect to x. Now, pick the right identity. You might want to consider using cos 2x equals to 2 cos square x minus 1. When you rearrange this, you should be getting cos square x in the form of cos 2x plus 1 divided by 2. What is it again that we got to do? Integration of cos square x with respect to x. Rewrite it to the form of cos 2x plus 1 divided by 2. Half is just a number. Leave it outside the integral and integrate only the expression of cos 2x plus 1 with respect to x. Perform integration like normal and you should get sine 2x divided by 2 plus by x with the constant of integration added at the back. Alright, now that you have seen how integration of cos square x and sine square x are performed, I would like you to perform the following tasks. Complete example 1 on page 32 in my manual, and please work on exercise A, odd numbered questions. Thank you and have fun.